Hey again, everybody. All right, so I am gonna do the two problems that we did in class. This is for periods 2, 3, or well, period 3, 4, and periods 5, 6. So, um, just here we go. All right, so the first problem had a 2.3 meter long crossbar with an applied force of 2.5 newtons, 2.5 newtons at the 0 centimeter mark, with the pivot point being at the 0.75 meter mark, and the total length being 2.3 meters. And we had to find the mass. All right, so I think a lot of you are starting to get this a little quicker, but if you need to take it slow, but I kind of just want to give you the setup. Well, torque 1, which is the torque due to the force, is going to simply be R times F, and R is 0.75, because that's the distance from the pivot point to the 2.5 meters, 2.5 newtons, which is my force. So 0.75 times 2.5 is 1.875. And I can do that as Newton meters, and already I can just say counterclockwise. Alright, torque 2, torque due to the short side. I use half the distance, because I'm only worried about the meter stick, so I use half the distance. So half of 0.75 is 0.375 is my R. And the M I want to use is 75 out of 2.3 total. So my M is 0.75 out of 2.3 meters total. That'll give a percentage times M, and that M really has to be multiplied by 9.8 to turn it into a force. That number, 0.375 times 0.75 over 2.3. A lot of you did the 0.75 over 2.3 separately and got 0.33 or 0.326. I'm going to leave it as 0.326, so my number might be a little different than yours, but that's okay. I'm going to get a torque 2 of 1.198. I'm going to leave 2 decimals. I have that variable m, that's the thing I'm solving for, and my units are Newton meters, and this is also counterclockwise. Torque 3 is my distance is 2.3 minus 0.275. So 2.3, I think I just said that wrong, minus 0.75, which is 1.55, but I have to use half that distance, because there's 1.55 meters from here to here, 1.55, but I only want to use half that distance, so that's 0.775. 0.775 meters, that's my R. My force comes about from the leftover distance on that side, which is 1.55, over the total distance, 2.3 m, again, times 9.8, and that's going to give me 0.775 times 1.55 over 2.3 times 9.8, which is going to give 5.118. I'll just do 2. That variable still stays, Newton meters, but this one is clockwise because it's on the right side. Alright, so I want to set up my equation. My two counterclockwise torques get added on the same side, 0.875 plus 1.198 m equals 5.118 m. Subtract the 1.198 from both sides. 1.198 m from both sides, so that goes away. You're left with 1.875 equals 5.118 minus 1.198, 3.92, 3.92 m. That's a 9. And then I have to divide by 3.92. So 1.875 over 3.92 gives you the final answer of 0.478 kilograms. Alright, hopefully that is good, and move on to the next problem. Alright, so next problem is you have a 30-meter long bridge or support or whatever you want to call it, crossbar, supported at the 25-meter mark with a 14-kilogram mass hanging at the 29-meter mark. So I'm going to set up my three different torques, torque 1, torque 2, and torque 3. Torque 1 is from the mass. It is 4 meters away from the 25 to the 29, so my R is 4, because torque equals RF. 4 meters away from the pivot point, 29 minus 25, times the mass, which is 14, times 9.8. The mass times 9.8 gives me the actual force. 4 times 14 times 9.8, 548.8 Newton meters, and that is a clockwise torque. Torque 2, the overhanging distance on the right, the short side, is 5. I want to use half of that. 5 meters from 25 to 30. I want to use half of that, which is why I have 2.5 as my R. The mass is going to be 5 out of 30. 5 meters out of the total 30 times m times 9.8, which is going to give 2.5 times 5 over 30 times 9.8, 4.083 m Newton meters, also clockwise. Torque 3, my total distance is 25 that's overhanging. I'll use half of that, so that's 12.5. My total mass is 25 out of 30, whatever that percentage is, times m times 9.8. 12.5 times 25 over 30 times 9.8 gives me 102.083 m as my variable, Newton meters, counterclockwise. That's my counterclockwise torque. Add up all the clockwises together, so that's 548.8 plus 4.083 m equals 102.083 m. Subtract the 4 from both sides, you're going to get 548.8 equals, subtract obviously the 4.083 m, I don't feel like writing it. You're going to do 102.083 minus 4.083, going to give you a nice number of just 98 m. Divide by 98. Divide by 98. M equals 548.8 over 98, which gives a nice even 5.6 kilograms. We expect that to be a little higher just because it's a much longer thing. So hopefully that helps. Got it done pretty quickly, those two problems. Really it's just finding these torques and figuring out clockwise, counterclockwise, and worrying about the percentages of the masses. Alright, I'll see you tomorrow. If you have any more questions, feel free to ask in class.